Hello folks, this is 2021 paper 1-2. I should have written this over here, but I forgot, and so I followed it up. October, November, number 16. This question is concerned with the chapter work, power and energy. As we can see the mention of the words kinetic energy, potential energy and so on. So a ball is thrown vertically upward into the air. It rises to the top of the path before beginning to fall vertically downwards. It rises and falls. Assume that the gravitational potential energy of the ball is 0 at the starting point. So here the potential energy is equal to 0. So I'd like to mention it as a PE1 equal to 0. Which statement about the ball is not correct? So we have to go for the not correct statement. So let me denote the energies here by these symbols. So here it is a KE1, here it is a KE2, it is a PE2, here it is a PE3, and here it is KE3. So if the whole height is from here to here is h, then I must have this P1 equal to mgh, because it rises to a height h, so the P should be mgh. Here it is 0, and according to the principle of conservation of energy, it comes to rest here. The Ke3 should be 0 here, and the K1 here should be equal to mgh. Also here, since it is at the midpoint here, the height is 1 by 2 here, so this should be equal to mgh by 2 and should be equal to mgh by 2 according to the principle of conservation of energy. So now let's go through the statements. As it rises, its kinetic energy is transferred to gravitational potential energy. It is true. So the K here goes on decreasing and this goes on increasing by the same amount. So we can say that the K is converted to the P here. Yes, it is a correct statement. It is a true statement. So this is not the answer. In number B, I have got at the midpoint of its path, the gravitational potential energy is equal to its initial kinetic energy. This is equal to its initial K. That means it says that P2 is equal to half mv square here, and that half mv square is equal to mgh. So it says that P2 equal to mgh, which is not true. P2 is equal to half mgh. So that's why this is not a correct statement, and this is the answer. Let's go to other statements also to see if some discrepancies are there. Number C, at the top of the path, its kinetic energy is 0. So here it says the kinetic energy is 0. It's true because velocity is 0 here. At the top of the path, its total energy is less than its initial total energy. So it says that here at the top of the path means here its total energy is less than its initial total energy. So it's true. It's because we have got the air here. Since it is thrown into the air, then definitely the total energy here should be less than here. If it is not air, simply free fall or free rise, the total energy would have been equal. But since it is air here, the total is less. But now the complication is that if there is air, will this thing be still untrue? Yes, of course it is still untrue. It is still untrue because this potential energy will be definitely not equal to this Ke. The P here will definitely not be equal to this Ke, so it still holds here. So that's why this is an untrue statement, and an untrue statement is going to be correct here. So choice number B is the correct choice.